Everyone, and welcome to lesson 31.2. Today's lesson starts on page 453 in your Springboard textbooks. You're going to need a pencil, a calculator, and that formula sheet where you started writing down our first formula from the other day. Now, speaking of the other day, we started talking about regular polygons. And remember, regular polygons are both equilateral and equiangular, which means that they have all the same size angles and all the same size sides. We call those specifically regular polygons. So for example, an equilateral triangle, which we know has all the same size sides and angles, would be a regular triangle. Okay, so regular is meaning equilateral and equiangular. Now, we talked the other day about the sum of the interior angles of a polygon, right? We talked about how the number of sides dictates that sum, right? The sum of the interior angles. There was 180 degrees total in a triangle, 360 degrees total in a quadrilateral. And if they were regular polygons, again, imagine that these were all the same size, like an equilateral triangle or a square, which is an equilateral quadrilateral. If we took those total degrees and divided them by the number of angles, in this case 3 for the triangle, each one would have to be 60 degrees. Or in a quadrilateral, a four-sided figure, if we divided them by 4, we would have 90-degree angles would be each one, right? Think of a square. Now, we can continue filling out this chart, right? We had a pentagon, total sum is 540, and if we divide that by 5, we get 108. And then 6 is 720. Divide that by the number of sides, we get 120. 7, we're going to have a fractional value. We see this. So again, we've talked about with the sum of the interior angles. The other day we talked about that formula, how it's the number of sides minus 2 times 180 degrees. Well, if we then want just what each interior angle is, so each interior, we're going to say each interior angle, that would be that same formula, but we're going to divide it by the number of sides to figure out how many we have. Because again, up above, we were taking that total sum and dividing it by the number of sides. Or another way of looking at this is you're taking the sum and dividing it by the number of sides. Now, we're going to skip over the next page, 454, and we're going to jump to page 455, where we see the vocabulary word exterior angle. And like we talked about interior angles in the previous lesson, an exterior angle is on the exterior of our polygon, on the outside of our polygon. Now, when we talk about the term convex polygons are what we traditionally think of when we think of a polygon. A non-convex polygon would be something like this, where you have an angle that's more than 180 degrees. This would be not convex because of that angle. But traditionally, we're dealing with convex polygons, where that's like our traditional, when you think of a polygon with those normal kind of size figures, right? And as we look here, we have these this polygon, and we want to think about if we had to look at these exterior angles, what is going on with these? What is the sum? Okay, remember, sum means you add them together. So take a moment to look at this, and as you add up these exterior angles, and you can play around with this and change too, for each of these figures, what are you noticing about the sum? Okay, so take a moment to play around with this using the link provided. But what you should be noticing here is that each time these angles are adding up to be 360 degrees. So if we add these up, we're getting 360 for the triangle, the quadrilateral, the pentagon, the hexagon, adding up all these angles, no matter how we change the shape, as long as it's staying convex, these are always going to add up to be 360 degrees, okay? So that is the formula for the sum of the exterior angles, no matter how many sides angles you have, they're always going to add up to be 360 degrees, which means that each individual angle for the exterior angles, so each exterior angle, we would call that, would be 360 divided by the number of sides. Okay. So we have some examples again to look at, and that's going to be on page 456, starting with number 14. Okay, we want to figure out what is the sum of the interior angles of a regular 24-gon. Well, again, the sum of the interior angles, this is number 14, we said is the n minus 2 times 180 formula. And if it's a 24-gon, we're going to plug in 24. So 22, after we subtract away 2, times 180 is 3,960 degrees. Now, what would the measure of each interior angle be? Well, remember, for each interior angle, we're going to take that total sum and we would divide it up by the number of sides, which again is 24. So if we take 3,960 and divide it by 24, we get 165 degrees. Now for number 15, it says, how does the sum of the measure of the exterior angles of a convex polygon differ if it's regular? Well, for the sum of the exteriors, remember, it's always 360 degrees, whether it's regular or not. So when they're asking us, how does it differ? The answer is it doesn't, because the sum of the exteriors is always 360, no matter what. Okay, so the regular polygons are not going to affect that. They're always going to add up to be 360. And again, we can go back to these were not necessarily regular polygons. They don't have the same size sides and angles, but they still always added up to be 360 degrees. All right, now in number 16, it says we have a convex polygon whose exterior angles are 70, 105, 28, and 32, and it's a pentagon, so it's 5 sides, and they're giving us 4 out of the 5. What's the measure of the 5th exterior angle? Well, again, the exterior angle has to add up to equal 360 degrees. So we're going to take those 4 that they're giving us, 70, 105, 28, and 32, and we know that that 5th angle will also be added to that, and altogether all 5 have to equal 360 degrees. So if we combine these, 70 plus 105 plus 28 plus 32, we get 235 degrees. And if we subtract those away from 360, our last remaining angle will have to be 125 degrees. All right, last but not least, number 17 says that each exterior angle of a regular polygon measures 24 degrees. How many sides does that polygon have? Okay, well, each exterior angle we know is 360 degrees divided by the number of sides. And they're telling us that each exterior angle is 24 degrees, and we want to solve for the number of sides. Okay? So this is similar to actually when we talked about trig, because we need to get the value for n by itself, right? So that this cancels out. So to get rid of that division, we're going to multiply. And then to get the n by itself, we're going to divide by the 24, right? So a lot of times we call this switch and divide because essentially what's happening is these two switch spots. Okay, so sometimes you'll see it switch and divide as we start solving, okay, or switch and divide from the beginning, because you're going to end up switching those. So then 360 divided by 24 would cause us to have 15 sides. All right, so take a moment to finalize your formula sheet, right? We have basically 4 formulas so far. The sum of the interior angles, which is n minus 2 times 180. and the sum of the exterior angles, which is always 360 degrees. If we want each one singular and interior angle, we would say that that's called each interior angle, right? Or one singular interior angle. You would take that sum formula and divide it by the number of sides. Or if we want each exterior angle, it would be the 360 degrees divided by the number of sides. Okay? So these are our 4 big formulas that we will work with more in class. Thanks, everyone.